Hi, this is Richa Garg. I'm here to present a Coursera assignment. I have been given few input variables and output variables, and I have to predict a net hourly electrical energy output. In this assignment, my modeling approach will be a supervised learning approach because I have a labeled data set, and I'll be using regression uh, to solve the problem because my goal is to predict a continuous numerical value. My performance metrics or output metrics are these three. First is mean absolute error. This will help me to identify the difference between the predicted and actual values. Second is RMSE. It will help me to figure out what are my large errors, and it will also provide an interpretable measure for the goal. Third is R square. This will help me to understand the model fit. In the feature selection, I have, for the time being, I've taken all the features, and all the features or input variable seems relevant to me for the output uh, given. Algorithms to consider, as I mentioned, I am using regressions. I'll be using linear regression. And further in the journey, I'll be using decision tree regression also to understand the nonlinear relationship between the input and output variable. The data I have split into two format, 80% and 20%. 80% is my training set and 20% is my test set. My validation strategy, I have taken two options, fixed validation set and second is cross validation set. In fixed validation set, I have split the 80% training set again into 80 and 20. And in cross validation set, I've used k equal to 5 to figure out the data set. In so Since I'm using linear regression model, I'll be using fixed validation set approach. Now here I'll be trying to evaluate, I'll be creating two models. The very first model is with all the features T, AP, RH, and V. Here I performed regression on it and I figured out R square and RMSE. Um, say in the second model, I have used T and V um, and dropped RH and AP because I figured that RH and AP are non-linear, have a non-linear relationship with the output given, and the respective percentage shows that RH and AP can be dropped. So the feature importance for TNV is higher when compared to RH and AP. Likewise, then I've added T square and V square so that the curve trends of the energy production be a simple linear model. So this model 2 I have created with the features of T, V, T square and V square. On this I have performed regression in which I have received R square and RMSE. Now comparing both the models, R square and RMSE, these are the outputs. So the conclusion is that R square of model 2 is lower, and R square helps me to understand the better fitment of the model. So hence we choose model 2. Now we have applied validation set again on model 2 and figured out R square and RMSE. So concluding the whole assignment, my modeling approach was linear regression based on supervised learning model. My model building were done on splitting of the data by 80 and 20%. And further, I've divided the training set into with a 20% of validation set. These all samplings were done randomly. My model evaluation, I have taken RMSE and R square as a primary evaluation metrics, and model interpretation. Using these all, we have figured out that the model 2 is a better fit because R square is lower and RMSE is uh, also similar on the RMSE of model 2 is bit slightly higher, but still on the similar lines of model. Hence, we choose model 2. Thank you.